Hi everyone, this is Praktis Sumatif of Chapter 2, Paper 2, question number 6. So we are given a wire of length 26 cm that is bent to form a sector shown in diagram 2 with the radius r. So this is r, this is r. Therefore, the remaining will form the arc length. So the arc length is 26 minus twice of the r. So we have to express theta in terms of r. So we use the circular measure, all right? Relate the arc length with the r. So S equals to r theta. So S is 26 minus 2r equals to r theta. So to make theta the subject, we divide both sides with r. So we have 26 minus 2r over r. We can leave this as our answer, or we write like this, 26 over r minus 2. Okay, that is A. Next, B. If the radius increases at the rate of 0.1 cm per second, so by the keyword, the rate of change is involved here. So let's write in terms of dr by dt, the rate of change of radius. It is given 0.1 cm per second. And at the instant r equals to 2, we have to find the rate of change in theta. So the d theta by dt is the one that we need to find. So first thing, we split it and we chain it using the dr by dt given. So do we have d theta by dr? That means we got to differentiate theta with respect to r. Okay, with that, we need to use whatever we found in part A. Okay, so let's rewrite theta equals to 26 r to the power negative 1 minus 2. So differentiate theta with respect to r. So we have negative 26 r to the power negative 2. Okay, let's write properly, negative 26 over r squared. So use this and put it in our d theta by dt. So d theta by dr will be negative 26 with the specific value of r, which is 2. So square the 2 times with dr by dt, 0.1 cm per second. Yeah? But this is theta. So our final unit should be radian per second. So let's use the calculator. Okay, let's get the calculator to get the value. So we have negative 26 over 2 squared. So that means over 4 times with 0.1. So we have negative 0.65. Negative 0.65 theta, the unit is in radian per second. So we found the answer for B part 1. Next, part 2. Part 2, we have to find the rate of change in the area of the sector. So dA by dt. So let's split this into 2 parts and chain them together using the r, because we can write A in terms of r. So at the side, A equals to half r squared theta. And isn't it theta is written in terms of r in part A, so substitute that. So we will have 26 over r minus 2. Okay, let's multiply that in. Okay, let's move a little bit. All right, so multiply this one into each and every item. So over here, we will have 13r minus r squared. So we differentiate the A with respect to r. So we will have 13 minus 2r. So sub this in to our dA by dt. So dA by dr is 13 minus 2r. R is 2. And then the whole thing we multiply with 0.1. The area, so the unit must be cm squared per second. So over here, 13 minus 4, which is 9, times 0.1. So we have 0.9 cm squared per second. Okay, so that's it for question number 6B, part 2.